right, so we are starting our second set of notes in Unit 2. It is the Sun, Earth, Moon unit. You are going to title your notes today, Seasons, and your essential question that you are writing down is how does Earth's tilt affect Earth's seasons? So go ahead and pause here if you're still writing that. So this slide is just a review, so hopefully you are listening to the video so you don't have to write this information down. Earth is 1 AU from the Sun, so that is 93 million miles away from the Sun. Sunlight reaches Earth through the vacuum of space as a transverse wave. Visible light, infrared, and UV radiation from the Sun all reach Earth's surface. Earth is a sphere and is heated unevenly. The equator receives direct sunlight all year. Sunlight at the pole is spread out and the poles are cold. Earth rotates, Earth's rotation is 24 hours, and Earth revolves around the Sun in 365.25 days. So again, that's just a review. Alright, so you do have to write this information down because this is new information. Earth's tilt. So would put that on the left side of your Cornell notes, kind of to separate your notes and make it look a little bit neat. That tilt is 23.5 degrees, which you already know. It always tilts the same way, so it's always going to be that 23.5 degrees. Earth's tilt is the reason for Earth's seasons, so that is a really important question, or you will see a question and that's going to help you find the answer. Seasons in the southern hemisphere are opposite of the northern hemisphere. So right now, currently in Australia, they have the opposite season as us. So we are in the fall and they are in the spring. Earth's tilt causes a difference in daylight hours at different latitudes. So make sure you draw and label the diagram shown to the right. Make sure that you are representing the different colors because the different colors is showing different temperatures. So colder at the poles, kind of a mild climate in that Tropic of Cancer. And then near the equator is very hot because they get that direct sunlight all year long. And then they have warmer temperatures closer to the equator. Go ahead and pause here while you're drawing that. Alright, solstice and equinox. So what I have highlighted, that should be on that left side in the Cornell notes. So this should be kind of in the middle of your notes, and then you have your March equinox and your June solstice. So for the March equinox, sun's rays are directed toward the equator. All locations on Earth have 12 hours of daylight. There is spring equinox, also called vernal. That is in the northern hemisphere. So March, spring, vernal equinox, that's us. And then in the southern hemisphere, like Australia, it is fall for them. So autumnal equinox, that's in the southern hemisphere. So as long as you know that what seasons are in what months, you should be fine with understanding the equinoxes and the solstice. So then we have the June solstice. Sun's rays are directed toward the Tropic of Cancer. So right about there. Daylight hours decrease from the equator to the South Pole. So from the equator to the South Pole, daylight decreases. Can't see that too much. So daylight decreases and daylight hours increase from the equator to the North Pole. And that's why in the summertime we have those longer days. It is summer in the northern hemisphere, so that is us, and then winter in the southern hemisphere. Go ahead and pause here if you're still writing. Alright, so then you have your September equinox. So the sun's rays are directed towards the equator again. All locations on Earth have 12 hours of daylight. In September, that is the first day of fall, so that is the autumnal equinox in the northern hemisphere. And then again, using Australia as an example, it will be spring in September for them. Okay, then you have December solstice. So the sun's rays are directed towards the Tropic of Capricorn. Right there. The daylight hours decrease from the equator to the North Pole. And then they're going to increase from the equator to the South Pole. It's important to note that the equator has 12 hours of daylight all year long. Go ahead and pause here if you're still writing. Alright, this slide is important because you are drawing and labeling. Your drawing must be large and neat, and you're going to use about 8 lines on your paper. This is what's going to give you a stamp. Obviously, you need to have everything else completed, but if you have your words all written down but you don't have your diagram, you will not get a stamp. So it's important to remember that you have March, you have September on the opposite side, so you can label this the vernal and then the autumnal. And then you have your December and your June solstice. Okay, make sure that you have all the information that is posted here. And as you're drawing this, you're not going to really draw your latitude lines, so make sure that you put that in the March and in September the sun is overhead at the equator, and then in June it's at the Tropic of Cancer. In December it's at the Tropic of Capricorn. So go ahead and pause here while you're doing this diagram. Alright, so sunlight on Earth. This is just kind of a picture to get more information on how the sunlight hits the Earth. So on that vernal equinox in March, it's hitting it at the Cancer, and then the autumnal at the Capricorn, and then summer solstice, winter solstice, you can see that northern is getting more sunlight and southern hemisphere is getting more sunlight. Go ahead and pause here if you're still looking at that slide. So this photo is just showing you a time lapse of pictures taken in the same spot, same time, different days. So it does show you that the different views of how the sun looks during different times of the year. If you want to read the rest of the information, go ahead and pause here. Alright, angle of inclination. Because Earth is tilted, the sun appears to be lower in the sky in the winter and higher in the sky in the summer. Make sure that you draw and label the diagrams shown below. So in the summertime, it's higher, and in the wintertime, it is lower. Also include the degrees when you are drawing this diagram on the left. Go ahead and pause here. I will include this link in the directions in Google Classroom. So it's just what is our position now on Earth. So you have a viewpoint of Earth, and you're kind of just looking at where the sun is. Make sure that you have this diagram drawn, just demonstrating that in the winter months the sun is lower, and in the summer months the sun is higher, or appears to look higher. Go ahead and pause here. Alright, so for your summary, you're going to draw the chart and fill in the correct answers. So you have your seasons. You're going to tell me the axis, how it's pointed. So in the winter is the axis pointing towards, away, or neither. For our seasons, you're going to tell me what solstice or equinox goes with the corresponding season. Tell me where sunlight is directed towards during each season. And then the length of the day. Tell me the length of the day during each season. And then at the end, you're going to answer this question. Why does the Earth have seasons? Or you can explain, how does the Earth have seasons? Alright, once you get that done, you are done with your notes. Your notes are going to be checked on Friday while you're taking your CVA, so make sure that you have all of it done. And that is it.